Hey guys, Mr. Backerberg here. In this video, we're going to be looking at how a derivative might fail to exist. So a function will not have a derivative at a point where the slopes of the secant lines, so f of x minus f of a all over x minus a, fail to approach a limit as x is approaching a. And there's a few instances where that can happen. So the first case we're going to look at, a function whose graph is otherwise smooth will fail to have a derivative at a point where the graph has a corner where the one-sided derivatives are different. So this graph is an absolute value graph. If we were to do the one-sided derivative as x is approaching 0 from the left-hand side, that portion of the graph has a slope of -1. But if we were to do the one-sided derivative as x approaches 0 from the right-hand side, that portion of our graph has a slope of +1. So because the left-hand derivative and the right-hand derivative are different, then this graph does not have a derivative at the x value of 0. Now the next place that a graph wouldn't have a derivative is any point where there's a cusp on the graph, and a cusp is kind of like a corner, but the graph is more rounded as it's coming in there. So what's happening at this cusp is as we get closer to this x value of 0, on one side our slopes are approaching +infinity, and on the other side our slopes are approaching -infinity. Another place where a function might fail to have a derivative is any place where there would be a vertical tangent line. So as this graph is coming into 0, if we were to form the tangent line right in the middle here, it would be a vertical up and down tangent line. So the slopes of the secant lines are approaching either +infinity or -infinity from both sides. And the last place that a function would fail to have a derivative is any point where there's a discontinuity, which can cause one or both of the one-sided derivatives to not exist. So in this example, we're going to look at finding a point where the function is not differentiable. So we want to find any points on the domain for the function f of x equals the absolute value of x minus 2 plus 3, where the function is not differentiable. So this is an absolute value graph. So it's a V-shaped graph, meaning that it's going to have a corner in it. So we want to figure out where the corner is happening. So using what we know about transformations of functions, normally an absolute value graph is centered right at the origin, but there's some shifting happening in here with this function. So that -2 inside of the parentheses is going to take kind of this center point of our corner and move it to the right 2 spaces. But then this +3 on the back end is then going to take it and shift it up 3 spaces. So we've still got this V-shaped graph. It's just been shifted to the right 2 spaces and up 3 spaces. So if we're trying to find any x values where this would not be differentiable, there's a corner on this absolute value graph happening at the x value of 2. This function is differentiable at every other x value, but not at 2 because of that corner happening there. That's going to be it for this video. Thanks for watching.